All of you are getting my screen?
Yes, sir.
Okay, fine. So, what we have discussed in last lecture? We were talking about the testing of logic circuits, right? Then we have studied the need why we should go for the testing of logic circuit. Then we have discussed the different methods to test the combinational logic and sequential logic. Clear? So, combinational logic testing, it has three methods. First one is stacked fault, then path sensitization, and third one is random testing. Coming to the sequential logic testing, it has uh, boundary boundary scan test, boundary scan part test, built-in self test, right? Then JTAG, that is nothing but boundary scan. So these are the different methods that are available for the sequential logic testing. So we were discussing, we have covered that stacked fault model. Now today we will discuss the path sensitization. Now what we have did in that stacked fault model, first we have identified the inputs, right? Then we have identified the internal connection of every what you can say logic gate to another, or in overall the circuit. Okay, now in this path sensitization, what we have to consider, instead of considering individual pin, we have to identify the path from input to the output, right? Means, for example, if we have to go for the stacked fault model test for this circuit that you are getting on the screen, how many conditions will be there? So there will be a four inputs W1, or four test inputs you have to apply, that is W1, W2, W3, W4. That means 2 raised to 4, that means 16 probable combinations you have to write. This is the first step. Then next, for home, you have to identify the wire, internal wires, internal connections. So A, B, C, F, this is the 4. Then again that W2, so I haven't mentioned the name here because this is the example of path sensitization. But if with this same circuit, if you have to if you carry out the stacked fault model test, then A, B, C, then that W2 will be D, W3 will be E, then W4 will be F, and we have to give some another name to that F. Say, let's say it's a G. Then how many internal wires we got? A, B, C, D, E, F, and output G, right? So 7 conditions you have to actually write, or you have to condition. And what is our rule? We have to consider one wire, right? Then consider that is connected to a logic 0. The same wire next time consider that is connected to a logic 1. They carry out this is the first way. Then again consider the next path or next connection, consider that path is permanently stuck to the logic 0. Then again consider that to permanently stuck with logic 1. Again check the conditions, right? So in all 7, and each condition has again 2 sub conditions. That means first is a stuck to the 0 and stuck to the 1. That means for A, B, C, D, E, F, and that output G, we have to write such a 7 to the 14 different test conditions we have to check, and again along with that 16 different probable test vectors. बरोबर है? किती फॉल्ट डिटेक्शन पॉसिबल आहे 14 cases and how many test vectors you have 16. So these many long you can say these many long test procedure you have to go for if you use the stacked fault model. Clear? Now what is advantage of this path sensitizing, right? Now here in this path sensitizing case, what we are doing here, instead of considering that individual wire, that means that A, B, C, again the F, G, D, E, F, and that output G. So what we will do here, we will not consider that internal individual path. What we will consider here, we will consider the entire path from the input to the output. येते लक्षात, म्हणजे तुझं इंडिव्हिज्युअल पाथ कन्सिडर करण्यापेक्षा एक टोटल पाथ कन्सिडर करायचा फ्रॉम इनपुट टू द आउटपुट. फॉर एक्झाम्पल हियर which one will be the first path? W1 A B, then to C, and then to F. This is the first path. Next path W2, right, to the B, to the C, to the F. This is the second path. Third path is W3, then C, then F. This is the third path. And last path will be W4 to F. Right? Means now you can assume, instead of checking that all 14 conditions, now we have reduced that headache to the only 4 conditions. See, test cases will be 60 because you have the 4 different inputs. So the test cases will be 2 raised to 4, that is 16. That is 0, 0, 0, 0 to 1, 1, 1, 1. But instead of writing that what we can say 14 condition, that means first one is for A, second is for B, then C, then F. Now your job get reduced to only write the 4 paths, and you check the that are 16 vectors with that 4 path, and that method is known as path sensitizing. That method is known as path sensitizing. So this is the advantage of having that path sensitizing method. समजलंय? म्हणजे इथं आपण काय केलंय, इंडिव्हिज्युअल वायर नाही कन्सिडर करायची, पाथ कन्सिडर करायचा, पाथ. बरोबर आहे? म्हणजे W1 to A, A to B, B to C, C to F. This is the first path. Next W1 to B, B to C, C to F. हा सेकंड पाथ. थर्ड कुठला येणार? W3 to C, C to F. This is the third path. आणि लास्ट कुठला येणार? W4 to F. This is the last path, that is fourth one. Right? So you have to consider in that way, and then you have to apply that 16 test vectors or test probable what we can say test inputs, and you have to check the output accordingly. Clear with this? Right. So this actually to sensitize a path through an input of NAND or NAND gate, all the inputs must be set to 1. Right. Then to sensitize a path through input of an OR gate or NOR gate, all inputs must be 0. That means what? For the input to that particular IC, you have to connect this circuit to that input, and you have to apply the different test vector to this path sensitizing circuit. In that way, you are checking the IC's fault, or you are checking the IC's working condition. म्हणजे हे पाथ सेन्सिटायझिंग जे सर्किट आहे, पहिले तुम्ही काय करत होता, तुम्ही ते प्रत्येक आयसी ची पिन जे आहे ते यू हॅव टू कनेक्ट आयदर टू दॅट 0 or to 1, राईट? किंवा त्या जे तुम्ही स्टकॅट फॉल्ट मॉडेल जे बनवलेलं आहे त्या मॉडेलचं प्रत्येक पिन तुम्हाला आयदर यू हॅव टू कनेक्ट दॅट टू अ लॉजिक 0 और लॉजिक 1, लॉजिक 0 और लॉजिक 1 प्रत्येक पिन आणि ते सुद्धा बरोबर आहे. पण इथं आता आपण काय केलंय, हे जे 5 सेन्सिटायझिंग सर्किट आहे की जे आपण तो तुमचं पुढचं डिव्हाइस किंवा हार्डवेअर चेक करण्यासाठी वापरणार आहोत, तर त्याच्यात आपण तो इंडिव्हिज्युअल पाथ जो आहे तो कन्सिडर करायचा बरोबर आहे. प्रत्येक गेटसाठीच तुम्हाला इनपुट आउटपुट प्रोबॅबल माहित असणार आहे बरोबर आहे. अँड देन you are expecting the output, also. So accordingly you have to go for the testing of hardware using path sensitizing. म्हणजे एवढं लक्षात ठेवा फक्त की इंडिव्हिज्युअल पिन तिथे टू द लॉजिक 0 टू द लॉजिक 1, परत दुसरी पिन ती लॉजिक 0 टू द लॉजिक 1, असं इंडिव्हिज्युअल पिन किंवा इंडिव्हिज्युअल कनेक्शन कन्सिडर करण्यापेक्षा इथे आपण काय करतोय, एक पाथ कन्सिडर करतोय टोटल. दॅट मीन्स with one test that entire path will get tested, right? With that one test, what we can say, the applied input, the entire path will get tested. This is the advantage of this path sensitizing method. समजलंय का? समजलंय का? All of you clear with this?
Yes, sir.
Okay. Now the next thing is this is all about the methods for the combinational. And see, I have mentioned there the third method, that is the random test method, right? So random test method means what? Then you have to go for either combination of these two methods, that means staccato fault or path sensitization, or you have to go for any other random method. रँडम टेस्ट मेथड म्हणजे काय, ह्यातलं कुठलीही एक वापरा किंवा ह्याचं दोन्हीचं कॉम्बिनेशन तुम्ही वापरा. दॅट इज नथिंग बट द रँडम टेस्ट मेथड. रँडम टेस्ट मेथड म्हणजे अजून काही वेगळी नाही. आयदर यू यूज दिस टू मेथड सायमल्टेनियसली और you can go for any one of the method. That is either you go for staccato fault or you go for path sensitization, depending upon your need and application you can go for, right? So that's about the random test method. Now we have discussed the different methods available for the what we can say sequential logic testing, right? So we have now completed the methods for combinational logic circuits, and now we will discuss the methods for sequential logic circuits. Now what are the methods available for the sequential logic circuit testing? First one is the scan part testing. Second one is a built-in self test. Again, in that built-in self test you have signature analysis, you have built-in logic block observer, right? And the last one is a boundary scan or JTAG, you can say, right? That boundary scan and JTAG is one and the same thing. Have you aware about that JTAG port, right? Nowadays many what we can say, that board, microprocessor, microcontroller, FPGA board has all that built-in JTAG port. So have you aware of that? So simply by connecting that JTAG wire to your computer or to that testing circuit, you can directly check that entire board, functionality of that entire board with the help of that JTAG port. And nowadays this facility is available with I guess even your ARM board has that JTAG port, ARM, right? So you might have aware of this. So these are the three what we can say the major techniques that are available with the sequential logic testing, right? Again I will repeat: scan part testing, built-in self test, and third one, again that built-in self test has again many sub techniques such as signature analysis, built-in logic block observer, linear feedback shift register, right? And the last one is a boundary scan or JTAG. Boundary scan or JTAG. Clear?
Yes, sir.
Okay. So probably in tomorrow's lecture we will start with this scan part testing methods. Okay, that means the testing methods for the sequential logic circuit. Okay, today we will stop here. If you have any query, you can ask me right now.